All right, so let's start here with finding the volume of the tetrahedron with vertices 0, 0, 0, 1, 1, 0, 0, 1, 1, and 0, 1, 0. Okay. All right, and so yeah, let's kind of draw this to get the picture. 0, 0, 0, 1, 1, 0, 0, 1, 1, so 0, 1, and then 1 in the Z, and then 0, 1, 0, right there. Okay, and so we get this, and then connect those. Yeah. Okay. Now, of course, what we're aiming at is the volume is the triple integral over region E of 1 dV, right? We just do 1 dV over a region. That gives us our volume. Well, if we look at it again, approaching it as between start from the XY plane, and then we're going up to kind of going up to this plane right here, this tilted plane surface, and so we can do our Z's from the XY plane 0 to that plane, right? Okay. So let's work on that plane surface. Well, that plane is the plane. We kind of have to come up with our own. Doesn't give us what that is. Yeah, so we got to get our own equation of the plane. It's 0, 0, 0. 1, 1, 0. And 0, 1, 1. Okay, let's get two vectors. Okay, so we get two vectors, and we can just start with just be 1, 1, 0 and 0, 1, 1, right? We go this to this, and then that to that. Yeah, it's very simple. And so our normal vector then. Remember we did kind of a, determinant. One way we did it was, and that gives us a vector. Let's see, cover that one up. So we have 1 minus 0. So I would be, I was thinking it was negative 1. What did I do wrong here? Zero, 1, 1. Oh, 0, 1, 1. That's what it was. That's what I got. Okay. I've got something wrong. Oh, this is what it is. 0, 1, 1, 1, 1, 0. Oh, is that what I did? Okay, yeah, on my notes. I got it. Okay, yeah, so it doesn't matter. All right, so we got 1 for x, and then the for the I, then the z's would be -1, right, and then +1. Yeah, okay, that's what it was. I did have those reversed. That's what I had in my notes. Okay, does that look okay? Remember, it's you do the opposite of it. So you got 1 minus, and then you do the opposite of that. Yeah. You got to alternate that sign. Yeah. Review blast from the past here. Okay. Okay, and so then then we just put that. That's our normal vector, and so it's our coefficients, if you will, times our x, and we'll just use this point here in our plane. So we wind up with just x minus y plus z equals 0. And so that would mean z would equal minus x plus y. So that's our plane there. And so that means our z's are going to range from what? Well, they're going to go from the xy plane up to that plane. So that'd be 0 to this. Okay. All right. Now for our xy's, if we look at this just from the top view, that'll give us what we might need for our xy's, x and y limits. And so the top view, well, it's it's this triangle right here, and so that's 0, 0, 1, 1, and then 1, 0. And so this triangle right here would be the top view. So you want to do it this way? Yeah, because then we can just say, well, the x's go from 0 to the this line, which would be, since that's 1, 1, y equals x, so the x's would go from 0 to y. And then the y's would go from 0 to 1. So this volume would be, the y's go from 0 to 1, the x's are going to go from 0 to y, and then the z's are going to go from 0 to -x plus y of 1, and then dz, dx, dy. Is the order I think we established there. Easy enough. So that's 0 to 1, 0 to y. The antiderivative of that's just going to be z, so you plug in the -x plus y, you got -x plus y. And so next we said we're doing the integral with respect to x, so that would be 0 to 1, -1/2 x squared plus xy from 0 to y. And we still have our dy. I think I better go get rid of this. And so that would be 0 to 1 integral, plug in the y for x, that'd be -1/2 y squared plus y squared. Oh, that's just 1/2 y squared, isn't it? Which the antiderivative of that would be 1/6 y cubed. 0 to 1, we got 1/6. Okay, so it's a little bitty tetrahedron, is it?